video, we'll be talking about predicting products for single replacement reactions. So let's take a look and really quickly review what a single replacement reaction is. In this example seen here, A plus BC yields. So if you notice, I have a single replacement reaction because I've got one single entity and a compound. And so what's going to happen is A is going to tap on B's shoulder. So A comes over to B and says, "Hey B, can you leave? I'd like to dance with C." So now A and C are now dancing together. And poor B has been bumped off. In other words, A replaces B. Single replacement. One single thing replaces the other single thing. And now A and C are dancing together. Now, a good thing to note in single replacement is you can actually have a cation replacing a cation, or you can have the anion replacing an anion, as you'll see me do today. Okay? Before we get to that, in order to determine if a reaction, a single replacement reaction will occur, there is something called the activity series that you got in class today. The activity series is a list of metals and nonmetals. And if you look at your activity series, what it shows you is the reactivity of these metals. And over here it says these are the most reactive, and as you go down they get least reactive. And the activity of the nonmetals are down here, and these are the most reactive, and these are the least. So in this example, or in this chart right here, lithium is the most reactive element, and gold is the least reactive. In an activity series, so let's take a look at this a little bit more blown up so you can see. So here's a little piece of the activity series kind of blown up for you here. We said lithium is the most reactive, and as you go down it gets least reactive. Okay? And then here are the nonmetals. We said fluorine is the most reactive, iodine's the least reactive. And so how does this pertain to predicting products? Well, in order for somebody to replace somebody, so in order for a cation to tap on a shoulder and say, "I want to replace you," they have to be more reactive. So the cation that wants to replace another cation has to be more reactive. So if lithium wanted to replace barium, if lithium walked over and tapped barium on the shoulder, it could replace it because lithium is more reactive than barium. If magnesium wanted to replace calcium, so if magnesium walked over and tapped calcium on the shoulder and said, "I'd like to replace you," it can't. It is not as reactive. It is less reactive. So no reaction takes place. Same thing with the nonmetals. If fluorine wants to replace chlorine, it can because it's more reactive. If chlorine wants to replace fluorine, it can't because it's least reactive. So chlorine cannot replace fluorine. Okay, let's remember that. And note that you're going to have to always use your activity series when you do single replacement. This you do not have to memorize. Okay? So you have to be more reactive to replace in single replacement. A metal has to be more reactive to replace another metal, or a nonmetal needs to be more reactive than another nonmetal. Okay, let's take a look at our reaction here. Well, we'll take this one first. Here we are. Strontium. So I've got one single A, and then I've got magnesium oxide, which is a BC. So right away I see this as a single replacement. So strontium is going to come and tap on magnesium's shoulder, and strontium is a metal and magnesium is a metal on the periodic table. So strontium, which is going to be the cation replacing the cation, metals are cations. Can strontium replace magnesium? Well, let's look and see. Again, the answer is only if strontium is more reactive. So think of it as if strontium is more reactive, it is stronger and it can punch out magnesium if it's more reactive. So let's take a look. Strontium and magnesium. Strontium is here, magnesium is here. Can strontium replace magnesium? Yes. it's more reactive. It's higher up. So this reaction can occur. So let's go ahead and predict these products. So now, remember, in a bubble up here on the top, I'd like to see your work. Strontium wants to come together with oxygen. Oxygen's charge is 2 minus. Strontium is 2 plus. So 2 plus and 2 minus give you SRO. You only need one of each to neutralize the charges. And who's kicked off to the side? Magnesium. And magnesium is not Hunkelbrief. It's not one of the 7 diatomic molecules, so no 2 needed. The last thing you'd have to do is balance. And if you notice, they're all balanced. 1, 1, 1, 1, 1, 1. Okay? So this reaction occurs. Let's take a look at the next reaction. All right, so calcium is a metal. So a metal can only replace a metal. In other words, a cation can only replace a cation. Calcium cannot try to replace chlorine. So a metal, you have to replace what you're like. A metal can only replace a metal. So calcium goes and taps on lithium's shoulder and says, I want to replace you. Can calcium replace lithium? You have to pull out your activity series. So here is calcium, and here is lithium. No, it can't. Calcium is less reactive. Look, it's lower down, so it cannot replace lithium. So what do? Well, because calcium cannot replace lithium, this reaction cannot occur, so you would write no reaction. No need to balance, no need to write anything out. No reaction. So some of these you don't even have to do. Okay? All right, moving on. Let's take a look at our last reaction here. Bromine and sodium chloride. Okay, again, single replacement because I've got one single thing and a team over here. Okay, so bromine comes over and it's going to tap on whose shoulder? Well, remember, a metal can replace a metal, and a non-metal replaces the non-metal. Non-metals turn into anions, so the anion replaces the anion. Bromine, if you look at your periodic table, is a non-metal. Which one's a non-metal here? Hopefully you said chlorine. So bromine's going to tap on chlorine's shoulder. That's the only way it can work. The non-metal can replace the non-metal. So can this reaction occur? Let's see. Is bromine more reactive than chlorine? Here is bromine. Ooh, I forgot the R. Here is bromine. Here's chlorine. This reaction cannot occur because bromine is less reactive. So no reaction. Okay? Good? How about we take a look at a reaction that actually can occur? All right, so let's take a look at this last reaction. So we'll say we have chlorine gas, and we have potassium iodide. So chlorine is a nonmetal. It will come over here and tap on iodine. Iodine's a nonmetal. Anion with the anion. Okay? Can chlorine replace iodine? We look and see. Chlorine is above iodine, so it's more reactive, so this reaction can occur. So now, up here in a bubble, chlorine is now going to bond with potassium. Remember, you always write the cation first. Potassium's in column 1, so it has a +1. And now it's going to be with chlorine, which has a -1. I just need one of each, so KCl. Plus, who got bumped off? Poor iodine. And iodine is one of the Hunkelbriefs, so it's one of the 7 diatomic molecules, so it gets the 2. Remember, cation gets written first, anion gets written second. So chlorine is bonding with potassium. Always remember that. Please write that down. And then I'm going to balance. So it looks like, put a big 2 here, and then a 2 here. So now I'm balanced. 2 Ks, 2 Ks, 2 Cls, 2 Cls, 2 Is, 2 Is. Everything is balanced. That's the end of this video.